Basic electricity, DC circuits. Part 4, Series Parallel Circuits. In the last program, you were introduced to parallel circuits. You built and tested a parallel circuit to see the relationship between voltage, current, and resistance when resistors are connected in parallel. In addition, you used mathematics to derive both the reciprocal formula and the product divided by the sum formula, both of which are used to determine the total resistance in a parallel circuit. In this program, you'll be introduced to series parallel circuits. You'll use a schematic diagram and learn how to recognize when resistors are connected in series and when they're connected in parallel. Then, you'll use this information to determine all values in the circuit.
As you've been shown, series circuits have only one path for current to flow. In addition, total voltage is equal to the sum of the individual voltage drops. Total current is equal to the current flowing through each of the resistors, and total resistance is equal to the sum of the individual resistances. Parallel circuits, however, have more than one path or branch for current to flow, with a common voltage for each branch. Total voltage is equal to the voltage drop across each branch. Total current is equal to the sum of the individual branch currents. And total resistance is calculated by using either the reciprocal formula or the product divided by the sum formula, and is always less than any of the individual branch resistances. Many of the circuits you'll test are a combination of both series and parallel circuits. By understanding the properties of both and recognizing which loads are connected in series and which are connected in parallel, you'll be able to determine all values in a circuit quickly and easily.
This schematic represents a series parallel circuit. The circuit has 4 resistors. The first, labeled R1, is 5 ohms. R2 is 10 ohms, R3 is 5 ohms, and R4 is 10 ohms. In addition, the total voltage of this circuit is 22 volts. Given this information, you can determine all values for this circuit. First, draw the circuit on a piece of paper. After the circuit is drawn, label all the points. Underneath your drawing, make 4 columns. Label the first voltage, the second current, the third resistance, and the fourth power. Under the column labeled voltage, list ET for total voltage. Then ER1, ER2, ER3, and ER4 for the voltage drop across the 4 resistors. Follow a similar procedure for the remaining 3 columns. When you're finished, the columns should look like this.
Now you can begin listing all known values. Referring to the schematic, the circuit is being supplied with 22 volts. Under the column for voltage, write 22 volts for ET. The schematic also gives the values of each of the resistors. R1 is 5 ohms. List 5 ohms next to R1. R2 is 10 ohms. List 10 ohms for R2. R3 is 5 ohms. List this for R3. Finally, R4 is 10 ohms. List 10 ohms for R4. You're now ready to begin determining all other values for this circuit. Returning to the schematic, the first thing you need to do is recognize which resistors are connected in series and which are connected in parallel. Being able to do this is one of the most important steps in reading schematics. Once you identify the resistors, you then can simplify the circuit. First, start with the resistors furthest from the power source, and then work back towards the power source. For example, R3 and R4 are connected in series with each other. This combination is connected in parallel with R2. In addition, this entire combination, R2, R3, and R4, is connected in series with R1. Having R3 and R4 connected in series with each other is the same as having one resistor with a value equal to the sum of the resistances of R3 and R4. Remember, in series circuits, the total resistance is equal to the sum of the individual resistances. R3 is 5 ohms. R4 is 10 ohms. Therefore, The equivalent resistance of these two series resistors is 15 ohms.
Draw the circuit again. Only this time, combine R3 and R4 into one resistor. After you're finished, your circuit should look like this. Now you can label each resistor again. Keep R1 labeled as R1. Do the same for R2. However, label the third resistor RA. Remember, RA represents R3 and R4, which are connected in series. The total voltage is given as 22 volts. Therefore, write 22 volts for the total voltage of the circuit. R1 is given as 5 ohms. Record 5 ohms on your drawing above R1. R2 is given as 10 ohms. Record 10 ohms next to R2. R3 and R4, which are connected in series, have a total resistance of 15 ohms. Record 15 ohms next to RA. Looking carefully at this circuit, you can see that R2 and RA are connected in parallel with one another. This combination is also connected in series with R1. Therefore, to simplify the circuit further, calculate the equivalent resistance of R2 and RA. To do this, use the product divided by the sum formula, which says total resistance for two resistors connected in parallel is equal to R1 times R2 divided by R1 plus R2. Substituting the variables from this circuit, you'll find that the equivalent resistance is equal to R2 times RA divided by R2 plus RA. R2 is 10 ohms, and RA, which is R3 and R4 combined, is 15 ohms. Therefore, the total resistance is equal to 10 ohms times 15 ohms divided by 10 ohms plus 15 ohms, or 150 ohms divided by 25 ohms. The equivalent resistance, then, of these parallel resistors is equal to 6 ohms.
You can now draw the circuit again. This time, you can combine R2 and RA into one equivalent resistor, which is connected in series with R1. Label this resistor RB. Keep R1 labeled as R1. The total voltage is still 22 volts, so record 22 volts on your drawing. R1 is 5 ohms. On your drawing, record 5 ohms above R1. Finally, you just determined RB to be 6 ohms, so record 6 ohms next to RB. When you're finished, your circuit should look like this, with all points labeled appropriately. Compare this with the original circuit. Notice that by simply recognizing which resistors were connected in series and which in parallel, you were able to use what you know about series and parallel circuits to simplify this circuit with 4 resistors into this basic series circuit with only 2 resistors.
Now, using this simplified circuit, you can easily determine the total resistance. Remember, in series circuits, total resistance is equal to the sum of the individual resistances. In this case, R1 is 5 ohms. RB is 6 ohms. Therefore, the total resistance is equal to 5 ohms plus 6 ohms, or 11 ohms. Label 11 ohms for total resistance, RT. Using Ohm's law, which says current, I, is equal to voltage, E, divided by resistance, R, you can determine the total current. The total voltage is 22 volts. The total resistance is 11 ohms. Total current, then, is equal to 22 volts divided by 11 ohms, or 2 amps. Record 2 amps for total current, IT. In series circuits, the current is the same at every point in the circuit. That is, IT equals IR1 equals IR2. Returning to the simplified version of the circuit, the current flowing through R1 is then 2 amps. Under the column labeled current, record 2 amps for IR1. Now that you know the current through R1, and you also know the value of R1, you can determine the voltage drop. Here's how. Referring to the triangle for Ohm's law, by covering E, you find that E is equal to I times R. In this case, the current through the first resistor is 2 amps. The resistance of the first resistor is 5 ohms. The voltage drop across the first resistor, then, is equal to 2 amps times 5 ohms, which is 10 volts. Record this for ER1 under the voltage column.
Returning to the simplified circuit, you can now determine the voltage drop across RB. In series circuits, the total voltage is equal to the sum of the individual voltage drops. In this case, the total voltage is 22 volts. The voltage drop across R1 is 10 volts. Therefore, the voltage drop across RB is 12 volts. You can verify this using Ohm's law. Remember, by covering E, you get E is equal to I times R. The total current for the circuit is 2 amps. In series circuits, current is the same through each component in the circuit. Therefore, the current through RB is 2 amps as well. Earlier, you determined the equivalent resistance of RB to be 6 ohms. The voltage drop across RB, then, is equal to 2 amps times 6 ohms, which is 12 volts.
Returning to the schematic, RB represents the equivalent resistance of R2 and RA, which are connected in parallel with each other. In parallel circuits, the voltage is the same at each point in the circuit. Therefore, the voltage drop across R2 is 12 volts, and the voltage drop across RA is also 12 volts. On your chart, record 12 volts for ER2. You can now determine the current through the second resistor using Ohm's law. By covering I, you get I is equal to E divided by R. ER2 is 12 volts. R2 is 10 ohms. Therefore, the current is equal to 12 volts divided by 10 ohms, which is 1.2 amps. Record this for IR2. Now you can easily determine the current through IR3 and IR4. Here's how. Referring to the simplified version of the circuit, you determine the total current to be 2 amps. In series circuits, the current is the same through each component in the circuit. Therefore, the current through R1 is 2 amps, and the current through RB is also 2 amps.
Remember, RB represents the equivalent resistance of R2 and RA, which are connected in parallel. In parallel circuits, total current is equal to the sum of the individual branch currents. The total current through RB, then, which is 2 amps, is equal to the current through R2 plus RA. You just determined the current through R2 to be 1.2 amps. Therefore, the current through RA is 0.8 amps. Now, RA represents the equivalent resistance of R3 and R4, which are connected in series with each other. When resistors are connected in series, the current is the same through each component in the circuit. Therefore, the current through both R3 and R4 is also 0.8 amps. Record this for both IR3 and IR4.
Using Ohm's law, you can determine the voltage drop across the third resistor. By covering E, you find that E is equal to I times R. The current, IR3, is 0.8 amps. R3 is 5 ohms. Therefore, ER3 is equal to 0.8 amps times 5 ohms, or 4 volts. Record 4 volts for ER3. ER4 then equals 8 volts. Referring to the schematic and the chart, do you know why? Earlier, you simplified this original series parallel circuit with 4 resistors into a series circuit with 2 resistors. Using the formula for voltage in a series circuit, you determined the voltage drop across RB to be 12 volts. RB represents the equivalent resistance of R2 and RA, which are connected in parallel with each other. Using the formula for voltage in parallel circuits, you determined the voltage drops across both R2 and RA to be 12 volts. Finally, RA represents the equivalent resistance of R3 and R4, which are connected in series with each other. You determined the voltage drop across R3 to be 4 volts. Using the formula for voltage in a series circuit, the total voltage of R3 and R4 is 12 volts. ER3 is 4 volts. Therefore, ER4 must be 8 volts. Again, you can verify this using Ohm's law. The resistance is 10 ohms. The current is 0.8 amps. Therefore, the voltage is equal to 10 ohms times 0.8 amps, which equals 8 volts.
The last column you need to fill out is for power. Using the formula for power, that is, power P is equal to current I times voltage E, determine the individual and total power dissipations. When you're finished, your answer should be as follows. Total power equals 44 watts, P1 equals 20 watts, P2 equals 14.4 watts, P3 equals 3.2 watts, and P4 equals 6.4 watts. Verify your answers by adding the individual power dissipations together. Remember, total power, PT, is equal to the sum of the individual power dissipations, P1 plus P2 plus P3 plus P4. Substituting the numbers into the equation, you find that the sum of the individual power dissipations is 44 watts. Let's stop here and review what you've been shown.
Number 1. Many circuits you'll test are a combination of both series and parallel circuits. Recognizing which resistors are connected in series and which are connected in parallel is one of the most important steps in reading schematics. This important step will enable you to simplify a circuit.
Number 2. The product divided by the sum formula is helpful in simplifying a series parallel circuit. This formula says total resistance for two resistors connected in parallel is equal to R1 times R2 divided by R1 plus R2.
Number 3. Once you simplify a combination series parallel circuit, you can easily use the formulas for series and parallel circuits to determine all values.